8 billion people jump at the same instant. The planet barely notices. But the humans? That is where this silly physics question turns into a disaster with sneakers. This idea has bounced around internet forums and bar arguments for decades. Simple question, can we really move the planet? But the answer isn't one thing. It's a cascade of physics, logistics, and a humbling reality check. You'd expect earthquakes, maybe a wobble in our orbit. But the truth is way more nuanced and genuinely a little laughable. The Earth is so absurdly heavy that our combined effort is like a flea stomping on a blue whale. The planet will barely shrug. The real catastrophe isn't planetary at all. It's what happens when you try cramming 8 billion people into one spot. So stick with me, because this is the most epic, futile, and chaotic moment humanity would ever face. Let's start with physics. The Earth tips the scales at roughly 597 sextillion metric tons. All of us, every man, woman, and child, a little under 380 million metric tons. So the planet outweighs every human combined by a factor of over 10 trillion. Wait, really? That's what the numbers say. When you jump, your feet press down and the Earth presses back. But with that mass difference, the Earth shifts less than the width of an atom. You wouldn't feel it. Nothing would. Imagine the faint shudder of a freight train rolling by, but a billion times fainter. Here's a doodle for you. Picture a fully loaded semi-truck thundering down the interstate, diesel roaring, heat rippling off the hood. All of humanity, every last one of us, would be a single grain of sand landing on that hood. The truck doesn't flinch. No shiver, no wobble, nothing. So the planetary recoil is essentially zero. But that's only half the equation. What happens when 8 billion bodies come back down and smack the ground at once? That's where the story flips from physics into pure human catastrophe. The landing is where the internet version usually cheats. All that energy has to go somewhere, yes, but the number is not planet cracking. Take 8 billion people, give each one a normal little hop, and you get something around 1 trillion joules. That sounds enormous because it is enormous for humans. It is in the rough neighborhood of a few hundred tons of TNT, not a dinosaur-killing asteroid, not the sun's full output, and not a supervolcano. If everyone landed spread across continents, the signal would smear into a weird global thud. If everyone somehow landed packed into one region, seismographs would notice a sharp artificial pulse, but the ground would not split open like a movie trailer. The real damage would be local and biological: ankles, knees, crowd crush, panic, people landing on uneven ground, and the simple fact that bodies are much easier to break than planets. Now the logistics get funnier and worse. If you spread all 8 billion people across Earth's entire land area, each person would technically get around 18,000 square meters, about several big house lots. Plenty of room, terrible synchronization. But that version would smear the jump across the planet and make the effect even less dramatic. To maximize the thump, you would need everyone crowded into one region, and then the experiment collapses before physics gets its moment. Even at packed concert density, 8 billion people would cover thousands of square kilometers. That is not a crowd, that is a temporary country made of elbows. There is no clean countdown, no perfect landing, no global hop. Transporting people, feeding them, giving them water, toilets, medical care, and a signal they all trust would be the largest logistical project in history. The planet is not the weak link. The line for the bathroom is. Here is the twist that saves the physics and ruins the stunt. Earth barely moves because momentum has to balance against a planet with almost ridiculous mass. But the human side does not get the same protection. A tiny hop is harmless in your driveway because the scale is small and landing is controlled. Multiply that by billions, then remove space, timing, medical care, water, toilets, and calm, and the problem stops being astronomy. It becomes crowd engineering. The planet does not crack. The pavement, ankles, barriers, signals, and emergency systems do. That is the joke hiding inside the question. The easiest part is moving Earth by less than a meaningful amount. The impossible part is getting everyone to jump without turning the setup itself into the disaster. So the bigger lesson is scale. A number can be huge and still irrelevant to one system, while devastating to another. 1 trillion joules sounds apocalyptic until you compare it with earthquakes, impacts, oceans, and the mass of a whole planet. Then it shrinks. Put the same energy into human bodies and infrastructure, and suddenly it matters. That is why this question is useful. It teaches you to ask, huge compared with what? Huge compared with a person, a city, a tectonic plate, or a planet. Physics is full of fake drama caused by missing context. The jump is not proof humanity is powerless. It is proof that scale decides what power even means. That comparison is the whole trick. The same event can be tiny for Earth and still disastrous for streets, knees, bridges, and stadiums, because damage depends on where energy lands and what has to absorb it. Here is the corrected lightning round. First, if all humans spread across land, each person gets roughly 18,000 square meters, but that makes the jump less synchronized and less dramatic. If all humans packed together at dangerous crowd density, they would still cover an area comparable to a large city region. Third, a normal collective hop lands around the trillion-joule scale, huge for infrastructure, tiny for Earth. Fourth, the planet's recoil would be absurdly small because Earth's mass is about 10 trillion times larger than humanity's combined mass. The most impressive part of this experiment is not moving Earth. It is realizing how fast the numbers humble us. So here is the ultimate mind blow. The same jump that shifts Earth by a microscopic amount could still injure or kill people if we tried to it badly enough. Not because the planet is fragile, but because we are. The Earth does not need to flinch for a human disaster to be real. Scale matters. At planetary scale, we are a rounding error with shoes. At human scale, 8 billion bodies moving together is terrifying power. The useful lesson is not that we can move mountains by jumping. It is that coordination matters more than force. Point 8 billion people at a foolish stunt and you get chaos. Point them at a real problem, and suddenly the thought experiment becomes much more interesting. Thanks for jumping through the numbers with me. Now give me your better use for one perfectly synchronized global action. One clap, one light switch, one message. Drop the idea in the comments. And if you want more thought experiments where the silly question leads to serious physics, subscribe and come back for the next one. The Earth may not care about our jump, but the math definitely does.